last lesson we did the transformation of the exponential function. So in today's video we'll be looking at the reflection of the exponential function, right? So now think about it. When you're talking about reflection, it's basically yourself looking at the mirror, right? It's basically yourself looking at the mirror, right? So that is what we mean by reflection, right? So in this case, when you're talking about reflection, it's basically the reflection translated. In this case, when you're talking about functions, is basically the translation about the y-axis and the translation about the x-axis, right? If you don't get what I mean, I'll explain in a bit, right? So if you look at this picture here, right, it's you looking at the mirror, and what do you see? Well, you see yourself, right? You see yourself, meaning you're seeing your reflection in that case, right? You're seeing the reflection. So that is what we're going to do in this case, right? There's nothing will change. So what we're basically doing is just writing the same function, right? Let's say the reflection of this function about the x-axis will be, in this case, something like that, right? Nothing will change. We'll have the same coordinates, but what will change are the signs. Let's say here you had 0 and 1, meaning here you'll have 0 and -1, right? So nothing changes, but the only thing that changes, of course, is the signs. Just like yourself, when you look at the mirror, right? When you look at the mirror, your hand, right? When you raise your hand, let's say here you have a mirror, right? It's you here, you're raising your hand, right? But in a nutshell, you are here, you are raising you're raising your left hand, but the mirror shows that you are raising your right hand, right? So that is what you mean by the reflection. That is what you mean by reflection, right? Yeah, I hope that makes sense. Yeah, so let us get into it. So when we're talking about reflection, you're basically multiplying the mother graph by a -1, right? By -1, or rather we're multiplying the input by the -1. Okay, let me explain that further. So let's say you have fx, right, is equal to 2 raised to the power x. Well, this is a mother graph or the parent graph, right? So when you multiply fx by -1, right, when you multiply fx by -1, well, we get the reflection of this function here, and hence we get a new function hx equal to -2 raised to the power x. So meaning we're getting the reflection of that. So now let us try to sketch these two functions here, the mother graph and its reflection. Let's say you have that okay, you'll have the y-axis, the x-axis, right? So this function here, we know something that looks like that, right, with the y coordinates of 0 and -1, right? So now what does this negative mean? Well, it means that we are multiplying all the y-axis, or rather all the y coordinates by -1. Remember, fx is the same as y, right? Fx is the same as y, so meaning you're multiplying all the negative you're multiplying all the negative y coordinates. I mean, we're multiplying all the y coordinates with -1. So let's say here we had on our mother graph, remember this is fx, on our mother graph we had 2, right? X equal to 2, and that's my y in that case will be 4, right? So in that case, if we multiply or rather we try to sketch the reflection of that graph, well, we will say, well, 0, or rather 0 is x, so it is not affected, so you will multiply the y coordinates only, right? So you'll say, well, 1 times -1, and hence that will give us 0 and -1. Then you say, well, 2 is not affected, so 2 is there, 2 is somewhere there, and then you say 4 times negative 4 times negative 1, well, that's -4, so meaning my coordinates will be somewhere there, and hence I'll have a graph that looks something like that. And hence my graph will look something like that. So you can see that here we have the reflection of the mother graph, or the reflection of fx, right? So this is hx, this is equal to 2 raised to the power x, and this is the same as 2 negative x. So that is what we mean by a reflection about the x-axis, right? So when you say the reflection about the x-axis, we're basically multiplying all the y axis, or rather all the y coordinates, like here. We multiply this by -1, we multiply this by -1, and hence we're multiplying all the y values by -1, and then you just sketch the graph as is, right? As easy as that. So that we mean we are reflecting about the x-axis, meaning this graph here is reflected across the x-axis. You can see that it is reflected across the x-axis, right? Yeah, it is swapped around. I can see here on this thing here, my sketch is not that perfect, but yeah, it is reflected, right? Rather, it is changed, right? You know, interchange. Yeah. So yeah, that is what we mean by a reflection about the x-axis, right? Okay, I hope this makes sense here, right? So now when we're talking about the reflection about the y-axis, that means we are multiplying the input value, or rather the dependent value, or rather the x here, the x value by -1. So that means if my mother graph is 2 x, meaning I'll have now hx equal to 2 negative x, meaning in this case now I'll be multiplying all the x values by -1. So let us see. So here we have the mother graph, looks like that. Okay, so here you have 0 and 1. So here again you have the same coordinates, 2 and 4. And then let's say here we have let's say when we have negative, let's say -2, right? -2 will have 1/4, right? Okay, so now that makes sense. Okay, so now how do we sketch this one here? Well, the inverse, or not the inverse, the translation, or rather the reflection of this mother graph here, right? So basically we will be multiplying all the x values by -1, because here we have a negative, right? So meaning, well, here 2 times negative, can we use a different color? So we have 2 times -1, that is -2, so meaning -2, this is 4 here, -2 is somewhere there, right? -2 is somewhere there, and then here again you multiply 2 times -1. Well, -2 times -1, that is 2, that's +2, so meaning +2, and 1/4 will be there, and then 0 times -1, well, that's 0, so meaning that doesn't change, and hence my function in that case will be something that looks like that, right? So that is what we mean by translation across, or rather about the x-axis, or rather the y-axis, right? You can see how you are able to translate this function here, or rather reflect this mother graph here about the y-axis, right? Still the same graph, but what we did is we just reflected it, right? So yeah, so that is what we mean by the reflection about the x-axis and the reflection about the y-axis. It's not that complicated. It's just when you have a negative here, you multiply. That means you're multiplying all the y values. You're multiplying all the y values by that -1, and the x values are not affected. But when we put a negative, when you multiply by -1 on the input, that means that the negative x, or rather that means the x values will be affected, and hence the y values will remain as is, right? So meaning we have to multiply all the x values by -1, and here similarly here you'll multiply all the y values by -1, right? I hope that makes sense, right? Okay, so I hope this makes sense here. So let us look at another the transformation that we didn't do. So the transformation, another transformation, I think we did talk about it yesterday. So when we have a equal to a raised to the power x plus -q, right? So in some textbook there will be d, it doesn't matter, right? So y is equal to a x plus -q. So what does this -q mean? Well, again, right, it means that the y value will be affected, because this is all happening like we are adding q. So meaning y, we added we said y plus -q, so meaning we are adding q to y, so meaning the y value will be affected. Now this here, what is our y? Well, our y is a vertical, I mean it's on our vertical axis, so meaning this is a vertical shift, right? So meaning this is a vertical shift, and hence in this case we are not multiplying, rather we are adding. So meaning all the y values you will be adding. So let's look at some example. Let's say we have come on. Okay, this is a vertical shift. Okay, so our mother graph is given as y is equal to let's say 2x, right? So that's our mother graph, right? So let us sketch the mother graph. It's something like that, going up, right? Now don't forget the asymptote here. Well, we have this asymptote, then here we have 0 and 1, and then there again we'll have 2 and 4, right? 2 and 4. Now what if, right, what if now we introduce a constant q, right? What will happen to the graph? Well, let's say you have y is equal to 2x minus 3. So what will happen to the graph, right? So let's say, okay, we'll have Cartesian plane there. Okay, so what will happen to the graph? Remember, now we are subtracting, right? It's a negative, so meaning we are shifting 3 units down, right? We are shifting 3 units down, so meaning this will affect the y values. In that case, it will affect the y values. And let's see how it affect the y value. So here we said y is equal to 0, so meaning in that case 0 minus 3 will give us -3, right? It will give us -3, so meaning my asymptote in that case will be at y is equal to -3. So that now in that case is my asymptote here. It shifted 3 units to the it shifted 3 units down, right? So here you have y equal to -3, and hence again here, so here the y will be affected, so meaning 1 minus -3, well, that is y 1 minus 3, that is -2, so meaning here we'll have -2 there. So here we'll have 0 and -2, and hence here again the x will not be affected, so meaning my x is still at 2, but my y will be 4 minus 3, which is 1, so meaning, let's say this is 1 here, and hence this point here will be something that there'll be something that looks like that. Note my graph is not drawn to scale, so this point here in that case will be 2 and 1, right? I hope this makes sense here. So this only affects the y-axis because we added, or rather we subtracted 3 from y, because this is y, right? This whole thing here is y. So when we introduce -3, we're saying, well, I'm subtracting the -3. I'm subtracting -3 from y, right? I'm subtracting -3 from y. So meaning, in that case, I'll have all the y-axis affected by that -3 rather than the x-axis, or rather the x values. I hope that makes sense. And yeah, let us move on. Similarly with the positive, when you have positive, it will move in the same, but in that case it will shift 3 units to the upside, meaning you'll have to add all the y values by 3. Here it will be 4 plus 3, which is 7, so it will be there. 3 plus 1 is 4, and then you say 0 plus 3, which is 3, hence my isotome will be there. Then my graph will shift like that, right? Yeah, so that is how the vertical shift, or rather when adding a constant q or d, doesn't matter, to the graph, affect the graph, right? Please take note of that. So a recap, right? We said we have now our function. We did everything, right? We said we have k a x plus c, or rather x plus -c, and then plus q. So this is how the exponential function, or the exponential graph looks like, right? So on the exam, they might ask you to find k, q, c, or a, right? They might ask you to find different or rather the missing values, right? Like q, c, a, or k, right? But we'll look at that later on, right? So now we're still looking at some basics of the transformation and reflections. And then what else we did is that the shift, right? We had to sketch the graph. We have to sketch the graphs based on the mother graph, right? Of reflections and transformations, right? And then I think that's all for the for the exponential function, right? So this is the only thing here. This is the standard equation of the exponential function. Yeah, apart from the mother graph, of course. The mother graph is that, but this is the standard equation of the exponential function, right? So in the exam, expect to get something like this. And yeah, when it comes to this one here, because now we have a point here, that means we have an x-axis, and hence one should calculate, or rather should calculate in that case the x-axis. So when you calculate the x-axis, you let y equal to 0, so that means 0 is equal to 2 raised to the power x minus 3, and hence 2x is equal to 3, and hence one then could calculate the value of x using logs. So meaning 2 log 2 x is equal to log 3, and then divide both sides by log 2, right, by log 2, and hence you should get let's say here you have log let's say you have log 3 of 3 and log 3 of 2, which is the same as 1 over log 3 of 2, right? I hope that makes sense. But again, you could just put this on a calculator and get your x axis, right? You could get your x-axis, right? Okay. So I hope this makes sense here. The standard graph, or rather the standard equation of the exponential function is given as that, right? We did explain all of these. We did explain the k, we did explain the q and the a, right? And also explained the reflection when a is greater than 1 and when a is less than 1, or rather and 0, right, in that case. So I hope that makes sense. Please do this on your own. We will look at more examples later on the video, or rather in the next video, but for now I just wanted to do the basics so that everyone is on par, or everyone understand what the exponential function looks like, right? Or rather the different types of x, or different types of transformation, and the shift, right, and how these affect the graph. Okay, so that's it for the video. I hope you find valued, and yeah, please hit that like button and subscribe button, and please share the video so that everyone will find this, or rather everyone struggling with the exponential will find the video and hence help them, yeah. And yeah, so remember, let me just explain this one more last time. Remember we said k, okay? So if you close q, we said k, like if y is equal to a x plus c, right? So if we introduce k, then what I'm saying y is times by k, right, to get k a raised to the power x plus c. So meaning all the y values will be times by k. That is what we mean here, right? We multiply by k, right? And when we introduce q, we're basically meaning that, well, y is plus or subtracted by q to get that y value. So meaning all the y values, in that case, all the y values will be subtracted or added by the constant q, right? I hope that makes sense. I was just trying to explain that in a simpler way, but yeah, I'll catch you on another one. Cool.